I've still got up on the board the example from the last video because there are a few additional questions we could ask about this function and its graph. And most of these questions are actually easier to answer once we've done the graph. Okay. So when we were talking about functions, we often talked about the domains and the range. So I want to give both of those in interval notation. Now for the domain, that's just the set of all x values that I can plug in. And there are no restrictions on what I can do to x. I can add 2, I can square, I can do the rest of the arithmetic. So the domain's going to be negative infinity to infinity, and that's going to be true for every single quadratic function that we have. Because I'm not doing anything that puts restrictions on x. I don't have any x's in a denominator, and I don't have any x's under an even root. Okay, the range. We can find that because we're able to graph this and because it's a parabola. A parabola that opens down like this has a high point. The y values don't go above that high point. So my y values are 4 and below. So my range would be negative infinity to 4, and I include that because I do have a point, the vertex, whose y value is 4. A lot of functions, it's going to be difficult for us to get the range exactly. But if I have a quadratic function whose graph is a parabola, I can. It's just that the y value of the vertex will be the high point if my parabola opens down. It would be my low point if my parabola opened up. Okay. Then we talked about functions that have relative maxes and mins. With a parabola, the vertex is always going to give me either a max or a min. The y value of the vertex is going to be either a high point or a low point. So if I were asked, do I have a max or a min? It's a max. Okay. What's the location of it? That would be the x value of the vertex. What's the value of the max? That's the y value of the vertex. Okay, and then we also talked about symmetry. Now this graph doesn't have any of the types of symmetry that we talked about. It's not symmetric about the y-axis, it's not symmetric about the x-axis, and it's not symmetric about the origin, and that's all pretty clear. But it does have a different type of symmetry, because we started with our parent function being just a parabola that was symmetric about the y-axis. But then we did some transformations. In particular, we did a horizontal shift. We shifted everything 2 to the left. So now, this is no longer symmetric about the y-axis, but it's symmetric about this line I've just drawn in. You'll notice I drew it as a dotted line because it's not part of the graph of my parabola. But this vertical line cuts the parabola into 2 equal pieces. And we call that the axis of symmetry. So in this case, it's just x equals negative 2. The equation of a vertical line is x is some constant. Okay. So be careful. If you're asked for the axis of symmetry, it's not negative 2 because the axis is a line, not a number. It's the line x equals negative 2. And it will always be the vertical line through the vertex, which means its equation will always be that x is just constant at the x value of the vertex. So with a lot of these functions, you'll be asked to graph them, but you may also be asked these additional questions about them.